Well, hi there, thanks for tuning into my YouTube channel. Jose Quiñones here, the CNC dude, with yet another CNC prowess of projects. You might remember my blue box conundrum a while ago. Basically, back then I wanted to show how you can make a bunch of something by reusing the origin or the 0, 0, 0 coordinates. In that case, basically what we did is that we use an edge finder to locate the coordinate 0, 0, 0, and then we use a work stop to ensure that the part was positioned every time on the same spot. Today I have a different problem. You know, for the previous project, I was basically grabbing my part from here, and all of the features were being machining on the side of the box. That's great, piece of cake, easy. But what happens when your body at work keeps on adding stuff and stuff and stuff into the box, and now you have to machine on this side, basically the top, well, not the top, but basically the side on the long, the opposite side of the long side of the box. Maybe you think, no biggie, just do it, right? Well, on my previous video, I think I posted a scene where for some reason the box jiggled itself out of the vise. Now when you flip like this and now you grab the part from here, now you have a longer section of material that is not being grabbed. So as you can imagine, the forces are gonna try, you know, basically you're pushing this way, you're pushing this way, you're pushing this way, and the amount of force that you have to counteract the force from the cutter may not be enough. The longer this is, the tougher it gets. So for months I told my friend at work, you know, we cannot machine this side because it's gonna get very tricky. I do not have a 90-degree angle plate to grab the box in such a way in which we can ensure that it's not gonna rock itself out of the jaws. But I thought of something, and that's what I want to share with you today. There is a way, I'm hoping, in which with a humongously big vise or a 90-degree angle, we can still subject or grab the piece that we're going to machine on the long side without the part flying away from the vise. Let's take a look. Okay, before I show you my trick of the day, let me try to illustrate as best as possible what the problem is here. So here is my box, and this is how we were grabbing it before. I did a little math here to get a kind of an important number. The jaw height is 2.1 inches and the box height is 5.71 or something like that. So when I divide the jaw height 2.1 divided by the box height 5.7, I get that the percentage of box that is inside of the jaws is roughly 33 to 34%. That tells me, actually, if I recall, it's like 36%. So that tells me that I have more than a third of the box below the jaws. Okay? Why is that important? Let me exaggerate here a little bit, except that is no exaggeration. It's the actual problem that we're facing. If I put my box like this and I grab it with the jaws, what I'm gonna see now is that this length is 8.72, but my jaws are still 2.1. So when I do the division, now I get that the percentage of this distance inside of the jaws is roughly 24%. Okay, 24% is obviously smaller than 33%. So that means that the force exerted by the jaws to grab the box is 24%. Is going to be smaller than 33%. Now let me illustrate what I think is happening here and what is going to be my enemy or our enemy during this run. As you know, I am carving a contour here, okay? Basically the hole that we want to make so we can put our boards and our features and of course access stuff inside of the box. Now, the blade, this is not a lightsaber, okay? This is not something like Luke Skywalker. We just chop off the Empire State Building with a single blow. This blade is actually applying a force in this direction. I mean, basically in both directions in X and in both directions in Y. That means that there is a force at a distance, okay? The rotational point for this box is this. It can rotate, okay? I'm not saying this is a motor, but basically, if you apply enough force, it's gonna rotate. Why? Well, if we remember from our physics class, when you apply a force at a distance from our axis, we get a torque, okay? And torque is basically the tendency to rotate across that axis. Now, here is my distance, 8.7, and the force is whatever force is the blade is exerting on the box. I don't know what the force is, but I can tell you that the torque when the box is like this is going to be larger than when the box is like this, because it's force multiplied by distance, and of course this distance is smaller than this distance. So that means that the torque that I'm going to get in this direction is going to be larger than the torque that I'm going to get in this direction. Alright? That's a problem exacerbated by the fact that now I have less percentage of my material grabbed by the jaws. I have 24% versus 33%. So I actually have two variables endangering or putting a hazard into my operation here. Even at 36%, 36% is the number I think I got from my calculation. Even at 36%, I was once able to observe the box getting loose and just working like that, and you know that box was literally hosed. It's not that box, some other box that I have at work, but basically that box was toasted because once the box moves away from the position, everything is lost. So we definitely do not want that rocking action to take place. We want this thing to remain as solid as possible, and the only way to avoid this torque is to apply a force stronger than the torque, okay? Now that is not necessarily simple. And also remember that as I apply force like this, I may be able to avoid this motion, but I'm still applying forces like this. I'm going to get a torque in this direction that is obviously going to be way bigger than the torque that I'm getting like this. So the only way that I can think of is to either have a jaw with wider teeth, I would say a vise with wider jaws, I should say, taller jaws, or I am going to trick it. I'm going to go, I'm going to cheat here. Here's what I'm going to do. I have these pieces of aluminum here that I have acquired basically by dismantling stuff that I acquired on the surplus place. There's a surplus auction every week here in Dallas, Texas, and every now and then I go and I get lucky and I get something. And these are pieces of aluminum that I've been using for a while. I've never actually worked on the aluminum because they are so handy as they are. So I'm going to put my pieces of aluminum like this. Now I'm going to crank this puppy. And although the jaws are applying the same amount of force they would have, that force is now being transferred across this height. So definitely this guy cannot move like this. It's pretty much impossible in my mind to imagine this guy moving like this, because I have literally counteracted that torque by applying this guy. Now, on the same fashion, or I should say on the other hand, this force like the one that makes the box rotate like this has not necessarily been counteracted by this, because there is really no material here. So the box will still move in X. But I think that the amount of friction provided by these two plates is considerably larger. So that should definitely enhance my probabilities of this part not slipping. So I think this is a cool trick to get very long pieces onto a vise that doesn't have tall enough jaws. So I guess in essence we could imply that these parts here are the jaws now. And that would make sense. Now notice that I don't want to use a piece of aluminum that is too tall. There's no need to go 100% or more than 100%, because this is already big enough, but also because I want to be able to reach these positions. So now I'm going to go with my edge finder and going to find my coordinates. Had I used a larger piece of material, I guess I could have used this side as my zero, because of course this surface is this surface if they are tight enough. But I prefer just using this, and there's of course no way of missing that one. So there you go, a cool trick to get long pieces onto your vise and avoid rockling action caused by unwanted torques. But you know, I have been telling you this is a great trick, but let's see it in action and make sure that it actually works. And here we go. Well, that looks very nice. The box didn't even twitch, which is precisely what I wanted. So we're in good shape. Now to finish the box. Well, there you go. A quick tip on how you can avoid your long object to rock itself out of the vise as you're machining this side. The next step on this project is to make holes on this surface, the bottom of the box. Well, how do I do that? This is too wide. The jaws of my vise cannot go wide enough as to grab the whole box in this dimension. In my next video, I'm going to show you how I am thinking that I can solve that problem. So yet another quick tip on how you can use the stuff around you to make it happen. Thank you for tuning into my YouTube channel. I'll see you next time.